In this lecture, we are going to explore how capturing by value works under the hood for Lambda functions. And we already know that Lambda functions are modeled by using functors behind the scenes, so this is really not going to be hard to understand. Suppose we have a Lambda function here, which is going to be capturing by value, and we are going to explicitly capture A and B for use in the body of our Lambda function. You see, we have access to A and B here, but they are going to be captured by value. And what we have inside our Lambda function here are really going to be copies of things we have on the outside. So we have our Lambda function here, we can call it with 10 and 20. And 10 and 20 are going to be our parameters that we pass to this Lambda function here. So we will have copies of them in the body and we will print them out as we see down here. Now, once we set up this Lambda function, behind the scenes, the compiler is going to generate a functor which is going to really capture the data and store copies in member variables that we set up in our functor here. So we will set up a bunch of member variables that are going to store whatever it is we have captured in our Lambda functions, and the data is going to be passed in the parameters of the constructor that is going to be called when the compiler creates an object of this functor here, and everything is going to fall in place. We can even prove this by using CPP insights and seeing what the compiler generates behind the scenes, but this is really the idea here. So we can even capture everything using the syntax we have here. And what this is going to do, this is going to set up a bunch of member variables which are going to store copies of the things that we have captured. One thing you should know is that we will only set up member variables for things we use in the body of our Lambda function. You see, we have captured everything, but we want to set up a member variable to capture some other var or some var here because they are not used in the body of our Lambda function here. So you should really know this. If you capture everything, the compiler is only going to set up member variables for the things you actually use in the body of your Lambda function. Another thing I want to bring to your attention is that by default, we don't have the ability to modify the data that we have captured in our Lambda function by value. So for example, if we capture A and B here by value and try to modify A, this is going to give us a compiler error, and the compiler error is going to say that we don't have the ability to modify this little thing. The reason is, in the functor that the compiler is going to generate to support this Lambda function, the compiler is going to make our function call operator const, and that operator want to have the ability to modify any member variable of the functor. So if we try to modify any member variable, the attempt is going to fail because we really are trying to do this inside the function call operator of the functor that supports this Lambda function here. But it is possible to remove this limitation, and you can do that by marking your Lambda function as immutable. And if you do this, you will be able to modify your data inside your Lambda function. But this is really going to make your code hard to follow because the behavior of your Lambda function is going to be different across function calls. So if we call this for the first time, it is going to increment A. If we call this for the second time, it is going to increment A again. And this is really going to be hard to follow. The reason for the limitation to not be able to modify the data that you capture in your Lambda function is to make the function calls you make consistent, and the functions will have the same behavior regardless on how many times you have called this function here. So if we call this Lambda function for the first time, A is going to be the same. If we call it for the second time, A is going to be the same. The only difference we will see will be coming from the parameters that we pass to this function here. But if we allow the modification of what we capture in the body of our Lambda function, the function calls are not going to be consistent because A and B may be different because we have the ability to modify them in the bodies of our Lambda functions here. This is what I want to convey here. Now that we know this, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is capturing by value under the hood. We are going to grab our template files and put them in place. Let's do that. And we are going to open this little guy in Visual Studio Code by dragging and dropping here. This is going to give us our main CPP file. We can clean it up a little bit and remove what we don't need. We are going to set up a bunch of variables that we want to play with. So we have A and B that we will be capturing in our Lambda functions, and we have some other variables that we are not going to capture here. We will try to capture A and B by value, and we will set up a Lambda function that does that right here. We can close the left sidebar to have some more breathing room. We're going to capture A and B in our capture list. We're going to set up two parameters, C and D, and we will print out what we have captured and what we have as a parameter data, and we will call our Lambda function here. So if we call the Lambda function, we expect to get A to be 7 and B to be 3 and C to be 10 and D to be 20 because these are our parameters here. Let's make sure we see that if we run this through our compiler. The build is going to be good, so we can clear. Let's bring up a terminal window to be able to clear and run Rooster. We're going to see that A and B are 7 and 3, and we have C and D to be 10 and 20. This is what we expect. But what we want to see is how the capture mechanism here works. And to see this, we will need to pass this through our trusty CPP Insights tool. So I am going to copy everything, Control A to select and Control C to copy. And I am going to hop over to CPP Insights. I am going to take out whatever I had in there and put in my code. You see, this is what we had in Visual Studio Code. And we will run this through CPP Insights to see what the compiler generates for this Lambda function here. And we know that it is going to generate a function object. So let's hit the run button here and see what we get. Our tool is done here. And you see that we have generated a function object or a functor. This is a functor because we have our function call operator. And you see that the function call operator is generated as cost. This explains what we said in the slides, that by default, we won't have the ability to modify the data that we have captured because our operator here is going to be cost. So we can't do any modification to the member variables through this operator here. Now, what I want you to see is that the data we capture is going to be modeled as member variables in our functor. So if we go down, we will have a bunch of member variables, A and B, and we're going to see that the data is going to be forwarded to our member variables through an initializer list that we have here. You see that the first parameter is going to be passed to A, the second parameter is going to be passed into B here, and the data is going to end up in our member variables. So if we go in our operator here, we're going to see that we're going to print out A and B as the data. This is going to be the data in our member variables. And after here, we're going to print out the data in our parameters, which are going to be 10 and 20 that we have passed here. So the main message is that the capturing mechanism works by using member variables that we set up in our functor. And the data we capture is going to be forwarded to the functor by using the constructor that the compiler uses here to set up our function object. You see, it is going to create an object of our functor, and it is going to pass the data that we have captured, and everything is going to work really well. This is how these things are going to work. Hopefully you can see this. And you should notice that because we have only captured A and B, the other things we haven't explicitly captured are not going to be available or usable within the body of this Lambda function here. That's what I want to convey. And by default, we don't have the ability to modify things. So for example, if we go inside and try to modify A again, we're going to see that we will get a compiler error because we really aren't allowed to do that, because the compiler is going to generate our function call operator as a const member function. We have seen that here. So we can't really try and modify our member variables from this member function. It can't modify any member variables, if I can say it another way. So if we try and build the code in our Visual Studio Code editor, we're going to get a bunch of compiler errors, and we're going to see that we can't really do that. Increment of a read-only variable. A is read-only from the perspective of this Lambda function. We have no business modifying it. You should really understand this. So that's the first thing I want you to see, but it is also possible to capture everything by value. So we can change this to capture everything. And the way you do that, you use an equal sign as we have seen before. So if we do this, we will see that our code is going to compile. We can try and pass this through our compiler. The boot is going to be good, and if we run the program, we're going to see that we will get what we expect. A is going to be 7, B is going to be 3, C is going to be 10, D is going to be 20. But when we capture everything by value, we don't have everything set up as a member function, and the functor that is generated to support this lambda function here. The only member variables we generate are for the things that we explicitly use in the body of this lambda function here. So because we are only using A and B, these are the things we are going to generate member variables for, and we want to have member variables for some var, we want to have member variables for some other var. And if we go back to CPP reference, let's grab everything and put our code in. We're going to remove whatever we had in there, and we're going to put in our new code. You're going to see that we are capturing everything by a value here, but we will only generate member variables for the things we are explicitly using in the body of our lambda function. And that happens to be A and B. So we will only generate member variables for A and B here. Let's try and run this through CPP Insights. And CPP Insights is done. We're going to see our functor generated here. And if we look around, we're going to see that we only have 2 member variables for A and B, because these are the things that we use in the body of our lambda function here. I hope this makes sense. Okay, we have said that we don't have the ability to modify what we capture in our lambda function by default, but it is possible to force the lambda function to allow us to do that. And we can do that by marking our lambda function as immutable. The moment we do this, we are telling the compiler to generate our function call operator as non-const, and that's going to allow us to modify the data we capture here, which is really going to be modeled as member variables in our class, which is going to be our functor. So now that this is mutable, we can go in and modify A and make it A++, for example. You're going to see that now we have this ability to do this. And if we run this program, we're going to see that the data for A is going to change across function calls. So we can go down here, for example, and say func and pass in 20 and 30. And we're going to see what we get if we run this code. Let's pass this through our compiler. The build is going to be good, so we can clear and run Rooster. We're going to see that for the first call, I think we should separate our calls with a separator to be able to follow this. This is going to make things easier. Let's pass this through our compiler again. And we can clear and run Rooster. Now we will see that after we call our function, we're going to have A to be 8 and B to be 3, because we have already implemented A in the body of our lambda function before we do any printout. C and D are going to be 10 and 20. We're going to put in our separator, and by the time we hit the printout, we will have incremented A again. You're going to see that A is going to become 9 and B is going to still be 3, and the parameters are going to be 20 and 30 for the second call we do here. But we are able to modify our captured data because our lambda function is marked as mutable. So let's go in again and capture everything we have in Visual Studio Code and put this in CPP Insights to see what the compiler is going to generate for us. We will run this through our tool and wait for the response here. And we will have our functor which is generated. We have our function call operator, and you see that now it is not const. We have the ability to modify our member variables that support our capturing mechanism. We are capturing by value, and these member variables are basically going to be storing copies of the data that we have captured in the context where this lambda function is. This is really all I had to share in this lecture, showing you how the capturing mechanism works by default. You should be careful because you don't have the ability to modify the data you capture by default. And if you want to have the ability to modify the data that you capture, you will have to mark your Lambda as mutable. But this is not something I recommend because it is going to make your code hard to follow. This default is put in place for a good reason, and the reason is to have consistent behavior from your Lambda function across function calls. And the only changes are going to be coming from the parameters that you pass to your Lambda function. This is exactly the same behavior we have with regular functions in C++ anyway, so we don't want our Lambda function to disturb that practice that's already been established in C++. Hopefully this is making some sense. If you have any problem, please don't hesitate to ask. I will do the best I can to help you out. For now, we're going to stop here in this lecture. In the next one, we're going to explore how we can capture by reference and how the compiler is going to model the functors that are going to be representing our Lambda function behind the scenes. Go ahead and finish up here and meet me there.